Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I am doing, please don't forget to subscribe, share my videos to your friends and to your friends' friends. That's the only way you can also help me promote my channel and refresh and keep me going of this very tiring work. So here is another example on frames. By energy methods, determine the horizontal displacement at B by virtual work method and the horizontal displacement at E by Castigliano's second theorem. Take modulus of elasticity 200 gigapascals and moment of inertia 500 times 10 to the 6 mm to the fourth for each member. So here is the given figure. So by virtual work for the horizontal displacement at B. So first let's compute the reaction at E by summing up moments about A. So RE times 9. So 0 equals RE times 9 plus 10 times 4. Then minus 20 times 11 minus 30 times 3. So from there we can solve R sub E equals 30 kilonewtons. Then summation forces Y. The horizontal reaction at A, summation forces X equals 0 should be 30 leftward. And summation forces Y, 30 minus 20 minus 10 is 0, so 0. So that's it. Then for the virtual forces, we apply a unit horizontal load at B because that's the principle. Then we solve R sub E again due to this unit virtual load at B. So R sub E times 9, 0 equals RE times 9 minus 1 times 3. So R sub E is 1/3. So summation forces X, AX is 1 to the left, and summation forces Y, we have 1/3 downward at A. So we select the following sections. For simplicity. So take note that at this section CD, big M is negative 10x, but here there's no moment, same sectioning. So we bypass or ignore this part. Same is true with EF. There is moment at this section due to 20 kilonewton considering the load just to the right or the load to the right of this section, but here there's no virtual force, so these two sections shall be ignored in computing the horizontal displacement at B. So we have three sections left, here, 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 and here. So if we consider this section, for simplicity, we consider the actual forces below it. You can consider this section and all the forces above that section, but we make sure that the equation is simpler because it will have so many terms. Anyway, the effect is the same. So we just consider this section and the forces below this section to simplify the solution. So therefore, EI delta B horizontal equals, for this section here, integral of 30x minus 20 times 2 plus x. And in this section, it is just 1/3 times x, or x over 3 dx, from 0 to 9. Then we proceed to this section and consider actual forces below this section here. So the moment in this section is 30 times x, and in this section it is 1 times x. So plus integral 0 to 3 of 30 times x, then times 1 plus 1 times x dx. Then in this section here, considering forces below it, we have 30 leftward and 30 rightward. That's couple, so 30 times 3, the moment at that section. Or 30 times 3 plus x minus 30x. So it reduces to 30 times 3. 30x is cancelled, or 30x will vanish because we have 30 times 3 plus x. So 30 times 3, 90 plus 30x, then minus 30 times x. So it's 30 times 3. Same is true with this. We have 1 times 3 moment at that section. So for the last integral 0 to 3 of 30 times 3, then times 1 times 3 dx. So using your calculator there, or by simplification and manually evaluating the integral, the first integral is 270, the second integral is 270 also, and the third integral is 30 times 3 times 3 times 3. That should be 810. So combining, the horizontal displacement that B is 1350 over EI. Now EI is 200 times 500, that's the shortcut, and the unit is kilonewton meter square, so it is 100,000 kilonewton meter square. So the shortcut to this is we just divide the entire value by 100 to convert that to mm. So the horizontal displacement at B is 1350 over 100, and it is 13.5 mm rightward. So next we apply Castigliano's second theorem to compute the horizontal displacement at E. We apply a force P at E horizontally to the right, and we have the same sectioning. So again, the reaction here due to the actual loads is already 30. We just consider the effect of P. So if we sum up moment about A, reaction at E times 9 equals P times 6, or minus P times 6. So therefore, the reaction here in terms of P, the vertical reaction at E due to the contribution of P is 30 plus 2/3 of P. 2/3 of P is P times 6 divided by 9. So 2/3 of P. Then summation forces X, this is P plus 30, 30 plus P, so P plus 30 to the left. And summation forces Y, this is 2/3, 1/3, 2/3 of P downward. But anyway, it has no contribution to moment because its line of action passes through the section. So again, the moment at this section is negative 10x. It is not a function of P, so therefore 0. The moment here is 20x, but it's not a function of x, so the moment is 0. So we again consider these three sections here. So EI delta E horizontal is equal to integral from 0 to 9 of quantity 30 plus 2/3 P times x minus 20 times 2 plus x. Then the derivative is 2/3 x dx of this moment equation. Then plus in this section here, the moment is quantity integral of quantity P plus 30 times x. And the derivative is x dx. 0 to 3 of P plus 30 times x, the derivative is x dx. Px, so the derivative is x dx with respect to P. Then finally in this section, we have integral 0 to 3 of P plus 30 times 3 plus x minus 30 times x. Then the derivative is 3 plus x. P times 3 plus x, the derivative with respect to P is 3 plus x dx. So prior to integration, we set P 0, it is invented. So this is just integral of quantity 30x minus 22 plus x times 2/3 x, 0 to 9. So the value is 540. Here, the integral is 30x squared, 0 to 3, so it is 270. Here, the integral is 0 to 3, 30 times 3 plus x minus 30x, or this is 90 times 3 plus x. So 0 to 3, the integral is 1215. Combining, delta EH is equal to 2025 over EI, and EI is set to 100 to express the answer in millimeters. So 2025 over 100. So horizontal displacement at E is 20.25 mm. So that's it.